Okay, number 3. Negative 4 times negative 3t plus 1 minus 7t equals 5t minus 4. Okay? So, looking at our list, looking at our sequence of events, do we have any distributive property that needs to be done?
Yes.
Yes, we do have distributive property. This 4 has got to be distributed. So negative 4 times a negative 3t is a negative 12t. Negative 4 times a positive 1 is a negative 4. Minus 7t equals 5t minus 4. Do we have any like terms that need to be combined on the left?
Yes.
That should be a positive 12. Sorry. Do we have any like terms that need to be combined on the left?
Yes.
Yes. We've done our distributive. Now we've got to combine this 12t and this 7t. 12t minus 7t is 5t minus 4 equals 5t minus 4. Can I determine now?
Yep.
What do I have?
Many.
This is many solutions because this and this are identical. If you have twins, you have many children. And this is many if you have twins, you have many solutions. Okay? If you have twins, you're going to feel like you have many children when them twins are babies and you trying to change diapers and do feedings in the middle of, twins make you pull your hair out. So, twins means many. But we could finish this if we needed to. Subtract 5t from both sides. And negative 4 equals negative 4. And I still have my twins. Twins is many. Okay? Twins are multiples. Multiple and many are synonyms of each other. You following me? That helps some of you maybe a little bit? So the answer here is infinite. Now, notice they're saying infinitely many, which is probably how you'll see it in a lot of cases. Infinitely many solutions. But to keep it condensed, we just call it many solutions. Okay? But it's infinitely many. In other words, no matter what you put in for t, you're going to get the same answer on both sides every time. Okay? Because think about it. If t equals, just think about it. If I didn't have anything but this equation and t equals 2, okay? If I put a 2 in right here, and right here, and I solve it, I'm going to get the same thing over here that I get over here. Right? If I put in any value, it doesn't matter what value I put in for t, I'm going to end up getting the same answer on the left and the same answer on the right. Okay? All right. Number 4. Let's shift this so you can see 4, 5, and 6. All right, number 4. 3/4 h plus 3 equals 6 times negative h plus 3. All right, first thing, do I have any distributive property on the left?
No.
Do I have any distributive property on the right? Yes. So I don't have to do anything to this right now. 3/4 h plus 3 equals 6 times negative 8 is a negative 6h. 6 times 3 is 18. Okay? Do I have any like terms to combine on the left?
No.
Do I have any like terms to combine on the right? Now, do I have variables on both sides? So what have I got to do? To the left, to the left. I move my variables and drop them on the left, right? So I'm going to add 6h over here and zero that out. And I'm going to add 6h over here. Now, that's where you're going to put in your calculator. That's where you're going to take the calculator and put in 3/4 H, or just 3/4 plus 6, and you get 27/4. So this is going to be 27/4 H plus 3 equals 18. Okay? Don't worry about how that looks right now. You're just going to add this and this. 3/4 plus 6. Now I subtract 3 from both sides. And 27/4 H equals 15. I've got to divide by 27/4 on both sides. So I'm going to divide 15 divided by 27/4. And I get 20/9. And if you notice, H equals 20/9. That is an answer choice.
When I did it in the calculator, it
Hang on.
changed it to a decimal.
Then you just
So I
have to
kept
change.
it as a decimal.
You can't. Well, but the decimal wouldn't have helped you because that's not how your answer choices are.
Like instead of getting
First the conversion.
27/4, I got 6.75.
But is the Desmos calculator giving it to you as a decimal? Because that one shouldn't have, because it just gave it to me as an improper fraction. If Desmos gives it to you as a decimal, hit that fraction button and change it to a fraction. If it gives it to you as a decimal in Desmos, does it give it to you as a mixed number or an improper fraction when you convert it?
I think like that.
An improper fraction. And you're going to leave it improper. You're going to leave it improper. Okay? Work with your fractions. Don't do a lot of decimal conversions. If it gives it to you as a decimal, change it back to. The only time I would leave it as a decimal is if I look at my answer choices and see that they're asking for decimals.
What was the answer number 2 from yesterday?
2 is C. Any questions about those?
Still gave me the right answer. It just wasn't the
But you still had to go back and change it to a fraction. Well, at some point you're going to have to. But listen to me, because when we are a hot minute away from doing slope, and when we get to slope, you will not be working with mixed numbers and improper fractions. I mean mixed numbers and decimals. Period. Everything will be an improper fraction. Okay? When we start doing slope, you will not be doing anything except fractions, whether they're simplified or improper. There will be no mixed numbers. There will be no decimals. It's not about whether or not yes, you can get to the right answer changing that to a decimal. I don't deny that. I'm not disputing that. But what I'm telling you, you got to start shifting your thinking. Don't shift your thinking and start working with these improper fractions. Okay? All right. Number 5. It went all the way out of there. All right. Which equation does not have a solution? Well, the only way you're going to be able to figure that out is if you work all of them. So we've got to look at A. A is 3y minus A equals 3y plus A. Well, I can tell you right now that's the answer.
You skipped 5.
Oh, I'm doing the wrong. Sorry. A. Well, that's not the answer. That's not the answer. That has no solution. Answer choice A in that one has no solution. I can just look at number 6 for a minute and look at answer choice A. How do I know that has no solution?
It's line to the plus.
Nope.
Because it's a negative 3y on the right and a positive 3y on the left.
Because, exactly. No, that one doesn't have no solution. I'm sorry. That one has, that one may have to be worked all the way out. If your variable, here's how you can tell if it's going to have no solution, okay? Here's some shortcuts for you. You ready? Tell me how many solutions does that have? Many. This one has many. We know that because we have twins.
No solution. Wait.
One solution.
No, one solution.
One solution. And it's going to be what?
Negative 6x.
It's going to be 0.
0.
Okay.
I meant x equals 0.
All right, so far, and I didn't mean to do that exactly, but now that one has many.
No solution.
That one has no. If they are identical, it's many. If they have the same variable term, wake up. If they have the same variable term and different constant terms, it's going to be no solution. Because what's going to happen is those variable terms are going to zero out. Because you've got to use the inverse of that 3x, negative minus 3x, minus 3x. That's going to zero out on both sides, leaving you 2 equals 4. Okay? So here it is. If they are identical, many. Identical or the same variable term, no. Well, the same variable term and different constant terms. Well, I mean, if they're the same variable term and the same constant term, it's many. Does that make sense? But if the variable term's the same and the constant term's different, it's no solution. And I don't care if you get to the point where you can look at them and tell me that without having to work it all the way out. Okay? Because you're going to get into this when your variables begin to have an exponent and you're going to have 2 solutions. Okay? But not with me. That'll come when you start doing quadratics. All right. Back to number 5 over here. That's just a little extra. Did that help anybody? Yes, no? Did that help a little bit?
So if we know if it was a 3x and then a 3x on the other side, but it was a 2 and a 4, then it'd be no, right?
Mm-hmm. If the variable terms are identical, same sign, same coefficient, same variable.
What if the variables didn't have the same signs? Like one was positive, one was negative.
Then it's depending on more than likely if they're the same variable term with different signs, it's going to be one solution, because you're going to end up having, when you do the inverse, you're going to end up having like signs. You're going to end up, it's probably going to be one solution. And more than likely, if the variable terms are different signs, or here's another one. If the variable terms have a different sign and the constant term is the same, what's the answer? No matter what the variable term is, the variable terms don't have to be the same. They just have different signs. Positive 3x and a minus 4x. But the constant terms are the same.
One solution.
What's going to happen? It's going to be one solution, but what is the what's the answer? What is the answer?
Zero. X equals
The x is 0. The answer is 0. Because what's going to end up happening with those constant terms is you're going to zero them out. Look, that's what we did right here. Look right here. It's like this one. Look at answer choice A right there. 3y minus a, let's just make that a 6, equals negative 2y. What did I say? The same?
Same constant.
Same
but
constant,
not, like,
different signs
signs
for
of the-
variable.
Different signs. All right, the constants are going to have to be opposites. No, they're going to be the same. Hang on, let me write it up here. Yeah, minus 6. All right, so we have different constant terms, different variable terms, same constant terms. You see this? If you add 6 to both sides to zero that out, well, that's not the first thing we would do. I'm sorry. I'm trying to hurry because we kind of got off on a little bit of a tangent. Is everybody with me right there? Now I'm going to add 6 to both sides. I get a 0 here and a 0 there. Every time you do that, you're going to get a 0 right there, which means you're going to end up dividing right here. Y is going to be 0. I mean, it's going to be 0 every time. Because you're going to end up zeroing out those constant terms and then dividing into that 0, and it's 0. Okay? You don't have to remember all of that. But when you start seeing these patterns is when you will, it'll really start to make sense. All right? So, negative 3d plus 7 equals negative 9. So on this one, we're looking for the one that does not have a solution. So we want no solution. So, well, I can tell you right now, that one has a solution. How many solutions does that have?
One.
That has one solution. We're going to subtract 7 from both sides. Negative 3d is going to equal upon negative 16. Divide both sides by negative 3. And d equals a positive 16 over 3. I'm just going to leave it like that. I mean, it's one solution, so that can't be the answer.
So when it gets down to a one-step equation like that, and it looks like something that we would normally do, does that mean that it's like a one, that it has one?
When you get to this point right here, if it looks like a regular normal two-step equation, it's one solution. Solution may be 0, and that's why on my puzzle that I'm sending you, that's why I'm making you tell me the value of x rather than 1, so you don't stop. Okay? You could have stopped. Some of you should be able to begin to look at that and say, hey, that's one solution, and never have to solve it. Okay? That's why I'm asking you what is the value. So that you have to solve it and tell me. So if it's got one solution, you're going to have to tell me what is the solution. But if it has no or many solutions, you just tell me no or many. Okay? All right, I don't want you skirting around it too much. So, 8d plus 7 equals negative 4 times negative 2d minus 4. All right? I have distributive property over here on the right. So I've got to do that first. My distributive property, negative 4 times negative 2d is a positive 8d. Negative 4 times a negative 4 is a positive 16. What did I tell you if
It's gonna be that one.
it is this one? What did I tell you if the variable terms are identical and these are different, it's no solution. Because look at what happens. I'm going to subtract 8d right here to move it over here, and that becomes 0. That becomes 0. So what I end up with is 7 equals 16, and that can't be. So it's no solution. This is no solution. That's going to be one solution. And that one's going to be one solution. And the solutions, yeah, that one's going to be one solution. Okay? Does that make sense? Is everybody with me? All right. Which equation has the solution y equals a? Does everybody have this? Do you need a minute to copy this before I scratch it? Has everybody got it? All right. Which equation has the solution y equals a? Well, 3 3y minus a equals negative 3y plus a. Well, I'm going to add this to both sides. That's 6y minus a equals a. Add a to both sides. 6y equals 2a. So it's not that one. Does everybody see what I did? Talk to me. Talk to me. I'm moving kind of fast, I know. And slow me down if you need to. Alright, that's answer choice A. Answer choice B. 2y plus a minus 7y equals negative 6y plus 2a. So I don't have any distributive property over here or over here, but I do have combining like terms over here. So I've got to put those together first. 2y minus 7y is a negative 5y plus a equals negative 6y plus 2a. I'm going to add 6y to both sides, and that gives me a y plus a equals 2a, and subtract a from both sides, and y equals a. So the answer is B. Do you see how the steps don't change even though there may not be numbers in there? Do you see now why knowing each and every step is critical? Huh? Remember I told you that doing the steps, you would eventually get to problems where you couldn't just look at it and know the answer without doing the steps? Justin, do you remember that?
Uh-huh.
Could you have gotten to this without knowing those steps?
Uh-huh.
Okay? That's why I have been so fanatical and so just held you to those steps, because you have to know the steps even when you don't have all of the numbers and all of the, when we start, this is what we call literal equations. They're not, you don't have all your values. The steps don't change, but you got to get it as far as you can. And as far as we can get it is down to y equals a.
So with equations that are like no or mini, are there ways to go back and check your answer, or do you just have to trust that it's correct?
You just got to trust that you know what you're doing. Is that one no or many solutions?
One.
No. It's no solution. Because,
They're different values.
right, the different variables are going to be different values. That's like saying 2 is equal to 4. Okay? You with me? Got your brains kicked in, huh? Number 7, what is the value? What value of P makes the equation true? Phew. 23. So basically what you're doing, and I'm just going to kind of talk you through the steps for doing this for the sake of time, because I need you to get the back of this done. Is everybody with me? So on this one, what you're going to be doing, I'm going to tell you what to do for this. First thing you're going to do is you're going to plug it in. You're literally going to take negative 20 and put it in for P. So it's going to be 23 times P. So you would have 23 times negative 20 plus 1/4 minus 1/4 times 8 times negative 20 plus 1 equals, all the way down, okay? Put negative 20 in for P. Let me just say. Then you're going to use the order of operations. You can use your calculator, but remember, using the calculator, it's not going to do the order of operations for you. So you're going to have to whittle it away, okay? What you are wanting to do is get to the answer that where the left is equal to the right. So you could do this as two separate, you could literally separate this into 23p plus 1/4 minus 1/4 times 8p plus 1. There's one of them. And then you have 5 times 4p minus 6 plus 10. There's the other one, okay? You can literally work these as though they are two separate problems. So plug in negative 20 right here and get the answer. Plug in negative 20 right here and get your answer, okay? If they're the same, then it means that equal sign right there is true. It means that, yes, the left side is the same as the right side. Okay? If it's plug in negative 1 over here, get your answer. Plug in negative 1 over here, get your answer. You've got to do that until you get to the one of these answer choices that gives you the same thing on both sides. Okay, so if you want to sort it into like a little mini tree map like that and do one and then the other until you get down to the bottom to get the answer that is the same on both sides of that tree. Because that's what you're trying to do. You're trying to see it's only true, an equation is only true if the left is equal to the right. It's like a sentence. This is this. The word, the equal sign, the key word for an equal sign is, right? Is equal to. So it means that this is this. Is the same as. Is, 2x plus 6. X is equal to 3, right? So I'm going to put my 3 back in. 6 is equal to 6. Okay? So what you're doing, is that true? It's not going to be true unless this side is the exact same as this side. Okay? Which equation is equal to? Which equation is equal to? So we've got to simplify this all the way down. So we've got to take this and get it simplified. Whew! So let's look at it. Let's just look at this. All right, so looking right here first. What do we see that we have to do first right here? So here's one equation. We're going to do this first. Let's get this one down as far as we can go, okay? We're going to work with these as two separate entities. All right? So I'm not rewriting all that. But what do we know we got to do first based on our little list over here? We got to distribute. So negative 4 times a negative 3/4. Is 1/4, isn't it? Or negative. Is that right? Not times, never mind. It's negative 3. Negative 3. So, this is negative 3, and I'm just going to write right on top of it. That times that is negative 3w. Plus 4 times 7 is 28. Right? Right? So, I have whew, sweet. This is really, w plus 6 over 3 plus negative 3w minus plus 7. Huh?
That's a positive 3.
No, it'd be
It's negative.
You're multiplying.
4 times a negative 3/4 is a negative 3.
Sorry.
All right. Now, over here. So we got to keep working. We're not done. So now, coming right here. I got to combine those like terms. So now I have 3w plus 6 all divided by 3 plus, and that's not going to be a plus. I'm getting rid of that plus. what is that going to be? It's actually going to be minus 3w plus 7. Okay? I got to keep going. Is everybody with me? I'm just working on that side right now. Now, here's something I need you to understand with this right here. I don't like working with this like it is right here. And when we get on into slope, we're going to split it. Okay? This right here is the exact same thing. All right, let me show you something over here a minute. Before I do that, let me show you something right here. I'm just using easy. Do you know that that is the same thing as this? Do you know that?
I forgot division.
No. 1/2 plus, we're going back to like the 3rd grade, 4th grade. 1/2 plus 3/2 is this the same thing as this?
Yes.
Huh? Because you're going to keep the denominator and add the numerator,
Yeah,
right?
yeah.
Right?
Mhm.
That hasn't changed when we get over here. Watch. Do you see that as far as terms go, I have a term plus a term all over a denominator, right? Do I have a term plus a term all over the denominator over here? Right here? Do you see that? Do you see the parallel a little bit? You see the comparison? All right, now watch. And the reason I'm showing you that is because I'm fixing to bust it up. And I'm going to do this. 3w divided by plus 6 over 3. All I did was broke it up and put it, and there's a reason for that, okay? There is a reason for that. You don't have to do that. But all I did was went from here back to here with it, okay? I just busted it up. Does everybody see what I did? Okay?
Miss Foster, I'm looking back at your work and you didn't multiply the 4 times the 7.
I did at the top. I didn't right here. Where?
The 4 times the 7, it should be 28.
It's right there. I just didn't show it. It's right there. Sorry. Okay. Does everybody understand how I got from here to here? Is everybody with me? Give me some kind of nod, thumbs up, something. And the reason for that is because we're fixing to use that 3 to break that on down a little bit more, because look at what we've got now. What we actually have now is 3 divided by 3. What is 3 divided by 3?
1.
So that's actually W, right? What's 6 divided by 3?
2.
W plus 2. So there's that, W plus 2. I'm bringing this down. Minus 3 W plus 28. Is everybody with me? See where I am. Told you we were going to be stacking it on top, stacking it on top, stacking it on top, stacking it on top, didn't I? You see how far back we're going and picking up stuff? Okay. Now, I'm ready. Now I can combine some more like terms. W plus a negative 3W is a negative 2W plus this 2 and this 28 gives me 30. Negative 2W plus 30. I think I know the answer. What's the answer?
Oh.
A? How is it A? Look at the answer choices. Which one has negative 2W plus 30 as an answer choice? That's part of the answer. D. Well, I'm done. Now, I might, but here's the thing. At that point, if you're sure of yourself with all of this, if you're sure of yourself, pick D and move on. Okay? But let's just make sure. Let's just make sure. Look right here. 9, all right, look at this. Those parentheses are irrelevant, except for one thing.
You gotta do
There's an
Order of operations.
I can't do order of operations. Ain't nothing I can put together. What do I know? All right, the parentheses mean what property? What have I got to do?
Distribute.
I got to distribute. What am I distributing?
Non-doing.
Positive, non-done, negative.
No, I'm not doing anything with that 9W.
A -1.
A